Today you're going to learn about the law of exponents. So we've already been talking about exponents a little bit, and we should know that 6 squared is the same as 6 times 6, which equals 36. 5 to the 4th power is the same as 5 times 5 times 5 times 5. I have 1, 2, 3, 4 5s. And I can figure out that it's equal to by multiplying them out. This is what is going to be the key to understand this part today, as we're looking at the law of exponents. We're looking at different things we're going to do with our exponents. Our first law we're looking at is when we multiply two numbers of exponents. So here we have 5 to the 3rd times 5 to the 4th. That is the same as 5 to the 3rd, 5 times 5 times 5, times 5 to the 4th. So we'll multiply that by 5 to the 4th, 5 times 5 times 5 times 5. If I look at this situation, I have 1, 2, 3, 4, 5, 6, 7 5s. So 5 to the 3rd times 5 to the 4th, the same as 5 to the 7th. Right? It's the same as 5 to the 7th. If I look at this, all I really need to do when I'm multiplying, the same base, I add the exponents. The base has to be the same, so I get all 5s. When the base is the same, and I'm multiplying two numbers in exponent form, I can just add the exponents. So if we look at some of these examples here, 2 to the 8th times, there's no space there, 2 to the 4th, it's still 2. Now I have a total of 12 2's. I had 8 2's times 4 more 2's gives me a total of 8 2's. W to the 5th times W to the 3rd, still be W. 5 plus 3 makes it W to the 8th. That's what happens when I multiply the same base number together with their exponents. I add the exponents. Now let's look at an example here where we're going to use exponents on a number with exponents. So we have 3 to the 4th here. To the cubed power. So I'm going to have that parentheses times itself 3 times, right? I'm going to have 3 to the 4th times 3 to the 4th times 3 to the 4th. Right? That's what I have there. I have 3 to the 4th times 3 to the 4th times 3 to the 4th. Well, we did just look at it. That'd be 4 plus 4 plus 4, right? Giving us 3 to the 12th. But I have 4 3's. Instead of adding the 4 plus 4 plus 4 plus 4, that's the same as multiplying, right? So when I have a number in the exponent area like this, raised to a power, I'm going to multiply the two exponents together. So I have a number with an exponent raised to an exponent. I multiply the exponents. 3 to the 4th cubed is the same as 3 to the 12th. So we can see we'd have 4, 4, 4. And we just looked at the last problem. If I'm multiplying numbers with an exponent, same base, I add 4 plus 4 plus 4, which is 12. Or 4 times 3 is 12. A little bit quicker. So when we have a number with an exponent and we're going to raise that to a power, we multiply the exponents. Some examples here. 7 squared to the 9th power. 2 times 9 is 18. That'd be 7 to the 18th. 7 squared times 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 7 squared, right? I had 9 7 squareds, which give me a total of 18, 7 times 7 times 7 times 7. K to the 6th to the 5th power. So okay, 6 times 5 is 30. I would hate to list all those out. That's what came out to be. 6 times 5 is 30. It would be K to the 30th power. Last term for today's notes here, last little part of exponents. If I have different bases, 4 and 7, but they're raised to the same power, both the 3rd power, we're going to look at what we do with that. So we have 4 cubed times 7 cubed. That's the same. 4 times 4 times 4 times 7 times 7 times 7. Now, what we can do with that, I'll look at this whole problem here. Because of our commutative properties, which allows us to say, okay, 4 times 7 is the same as 7 times 4. I can move my numbers around here in the problem. This is the same as saying 4 times 7 times 4 times 7 times 4 times 7. If you did what's in the green in your calculator, and you did this problem over here in red and blue, you're going to get the same answer. They're the same thing. But now look at what we have. We have 3 groups of 4 times 7. So we have 4 times 7 cubed. I keep the cubed because I'm going to have 3 4s and have 3 7s. If you think of that distributed property, you can distribute that cubed to both of them and get back to where we started at. But now I can do that multiplication without doing 4 times 4 times 4 and 7 times 7 times 7 first. Right? 4 times 7 is 28 cubed, right? It would be 28 cubed. So when my exponents are the same, but my bases are different, I can multiply the bases. Some examples down here. 3 to the 8th power times 5 to the 8th power. I'm going to keep it to the 8th power. 3 times 5 is 15, still to the 8th power. H to the 6th power, G to the 6th power. Both raised to the 6th power. H times G is G, no space. And that is all to the 6th power. I do need to put the parentheses around here, so it's not just G to the 6th. Over here, I do not need parentheses because it's one number, 15. Here I have 2 things, I have an H and a G. So I do need to make sure I keep those in parentheses. What you're going to do now is you're going to do what's called a quick check. You're going to answer 5 questions here. You're going to submit those online to me. That way I can quickly check to see if you understand what you watched in the video here. A few things here with exponents as we're doing these. You're going to use, I would call this the caret button, right? To type in exponents into the online question. Example, if you had 2 to the 7th power, type it like 2 caret 7. You can find that caret button by typing hitting shift and the number 6. It's right above the number 6. So you have 5 problems now. I want you to answer these 5 problems. I'll do it on my paper first, and take those answers and type them into the online questions, right, and hit submit.